Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 438 that says find all anagrams in a string. So yes, this is one of the very famous question, and also you can see the number of likes here. It's nearly to 10k. So this is one of the famous question of string data structure with a hash map or sliding window data structure. So yeah, today in this video we will discuss the complete approach as well as code for this video. So let's begin. So here you are given two strings S and P, and we need to return the starting indices of P anagrams in S. So what does anagram mean? So anagram means it's just a rearrangement of letters of a word or a phrase. Okay, so anagram you can think of it as a permutation. So let's say you have some string like A, B, X, Y. So what are different possible anagrams? One possible anagram is A, X, B, Y. Another possible anagram is A, B, Y, X. So similarly X, B, Y, A. So these are different possible anagrams, or you can say permutation of a string. So you need to find anagrams of a string P in string S, and you need to return the starting indices of the anagrams. Okay, so let's say this is the string S and this is the string P. So where you will find the first anagram of P in S. So as you can see here, this is the first anagram, right? CBA, this is the anagram or permutation of this string, right? So yeah, this starting index is 0, so we put 0 in our answer. Then where is another AB? No. EBA? No. BAB? No. ABA? No. BAC? See, this is the second anagram of this string P in string S, right? And starting is this. So let me number is 0, 1, 2, 3, 4, 5 and 6. So 6 is the starting index, so we push that in our answer vector. Is there any other anagram of P in S? No. So yeah, till here we will return our answer. Okay, so I hope you guys understood the question and the test case. So if you take a look at this test case, so here AB is the first anagram at 0 index, then this BA is the second anagram at index 1, and this AB is third anagram at index 2, right? So this is how there are 3 anagrams possible of the string P in this string S. So here let's say let me take this example only. What we are doing, we are checking, let's say we are checking for this window, right? What is the window says? The size of the window would be equal to P dot size, right? The size of this P string. Okay, so we are making a window of this P size, and we are check, does the frequency of all the characters in this window matches the frequency of these characters. See, we need to check anagrams, and for two string S1 and S2, two string would be anagrams of each other. Then what would be the case? The only case would be the frequency of all the elements of S1 would be equals to frequency of S2. See, as you can see here, A repeat once, B repeat once, X repeat once, Y repeat once. So in any of the anagrams, the frequency of the characters remain the same. So in order to check if this window is this window substring is an anagram of P, then what we need to check? We need to check frequency. Okay, and so for that what we can use hash table or hash map. You can say hash map. So yeah, we will do this. So this is our first window. If we get our answer, then we will push the index in the answer table. Then we will move ahead. Now we will take this as the second window. So every time we change our window, what we will do? We will push the we will remove the frequency of the last character and add the frequency of the new character. So for an example, let's say the frequency of this window is F1. Now in second iteration, what we will do, F1 minus character of C, that means reduce the frequency of characters of C, and F1 plus E, character of E, you will increase. That means you are taking this window. Then this window, what you will do, then from this, let me name it, so this becomes F2. So from F2 you will, what you will do, we will remove the B, that means remove the frequency of B and add the frequency of next character, that is this B, right? So this is how you will try to make all the possible windows. So are you guys understanding the intuition of why we are using sliding window? Because for each index we are checking the starting, means let's say this is the starting index, is anagram is possible, then this index is anagram possible, then this index is anagram possible, and for that to check if the anagram is possible, we are taking a window of size P dot size. Okay, so for this till this window, then this window, so we are changing this index, starting index position of the window each time, and we are checking for the frequency, right? And this is how we will check for the frequency only in one go. We won't again start calculating frequency of all the characters. We will just remove the frequency of previous character and add the frequency of a new character. So this is how we will maintain the hash table, and this is how we will slide the window. And whenever if the frequency matches with the frequency of S2, then what we will do, we will push I to our answer. So yeah, that's all for the approach part. So I hope you guys understood how we build the intuition and also how we would approach this question. Our approach would be this: by adding one frequency to the hash map and removing the previous frequency, yeah, and maintaining the this window of size p dot size. So this is our approach to solve this question. So now let's move on to the coding part, where we will code for this solution. So let me write initially one base condition, that if p dot size is greater than s dot size, then what we will do, we will simply return one empty vector. So why this? Because let's say we need to find permutation or anagrams of p in the string s, but if p is only greater than size than s, then there won't be any possible anagrams in the string s. That's why this is the base condition we wrote. Now after this, let us take two frequency map, frequency 1 of size 26 and initialize it to 0, and frequency 2 of size 26 and initialize it to 0 as well. So this is where we will store the frequency of a window of size p dot size in s, and this is the frequency of all the characters of size of a string p. Okay, so now what we will do, we will loop from I is equal to 0, I is less than p dot size I plus plus. So we are initializing the window of size p dot size. Okay, frequency 1 of s of I plus plus, and similarly we would do for this another string p. Now after this, what we will do, we will traverse from I equals to 0 up till I is less than s dot size minus p dot size. Okay, because this is the last, this is where our last window will be there, and we will do I plus plus. Now we will check if frequency 1 equals to frequency 2 or not. So since this is a vector, you can directly check if both the vectors are same or not. Okay, so so here this will check all the 26 elements of frequency 1 and all the 26 elements of frequency 2, and if all are matching, then what we would do, we would simply push the index to our answer. So for that, let me make one answer variable, and what we would do, we would simply do answer dot push back the index I. Okay, now afterwards, what we have to do, we have to simply do frequency 1 of s of I. So here one thing I forgot, I have to do minus a just to be in the brackets of size 26. So yeah, and for that I did minus a. Now here what one thing I have to do is remove this current element I. So s of I minus a minus minus, remove the frequency and add the frequency of the next element. The next element would be frequency 1 of s of I plus p dot size. Why p dot size? Because our window is of p dot size, right? Minus character a plus plus. Okay, so yeah, and in the end, so using this, all the windows will be checked, but our last window would be remaining. And for that, what we have to do, if frequency 1 equals to frequency 2, then in that case we have to take this last window, that is this I. We have to do answer dot push back s dot size minus p dot size. Okay, so yeah, and here we would simply return answer. So I hope you guys understood the code. We are simply doing this, removing the frequency of previous and adding the frequency for next element. If frequency, what is the, okay, so now let us try to submit this. So yeah, as you guys can see, our code got accepted. So I hope you guys understood the approach as well as the coding part, and if you have still any doubts, then do let me know in the comment section. So let's say the size of string s is L1, the size of string p is L2, then our time complexity would be L2 plus 26 times L1 minus L2. Why this? Because this run for L2 times, Okay, and this run for L1 minus L2 times. But this checking of this frequency, this will internally take what, S1 26 times, because it is of size 26. So so our time complexity is this, and our space complexity would be big of 26 for the frequency, or you can say it is as a big of 1. So yeah, that's all for the time and space complexity. So make sure you like this video and subscribe to our channel. Also, one thing to note here is that I'm posting the job opportunities in the community section. So make sure you subscribe to our channel to get the notification. And yeah, make sure to also like this video. Thank you.